When we think of programming, we imagine glowing screens, the click of keyboards, and endless lines of code. But what if I told you that programming didn't begin with computers? What if it began with humans thousands of years ago? Today, we're going to uncover the forgotten story of the very first programmers, people who wrote instructions not for machines, but for reality itself. Stay with me, because this journey redefines everything you thought you knew about technology. At its core, a program is really quite simple. It's just a sequence of instructions executed in a specific order to produce a predictable result. This fundamental idea existed long before electricity was ever harnessed. Think about it. Ancient peoples used logic, repetition, conditions, and loops, the very same concepts that power the software on your phone and computer today. Their tools were different, sure. They used stone, water, and stars instead of silicon. But the thinking, the fundamental logic, was exactly the same. They were creating programs, just without the digital interface. The word algorithm itself gives us a clue. It comes from the name of the brilliant Persian mathematician, Al-Khwarizmi, who lived way back in the 9th century. His groundbreaking work described clear, step-by-step methods for solving complex mathematical problems. And that's precisely what an algorithm is today. But the story goes back even further. Archaeologists have unearthed Babylonian clay tablets, thousands of years old, containing detailed instructions for calculating square roots, predicting the motion of planets, and solving complex equations. These weren't just random guesses or observations. They were precise, repeatable procedures designed to get a specific outcome every single time. In other words, they were writing code, just in a language of numbers and symbols pressed into wet clay. These ancient mathematicians were, in a very real sense, the first coders. Now let's jump forward to ancient Greece. Here, we meet a genius inventor named Hieron of Alexandria. He designed incredible machines that could follow predefined paths of instructions. Imagine this, fully automated miniature theaters where puppets moved on their own. Doors opened and closed, and scenery changed, all without human intervention. How? He used rotating drums with carefully placed pins. Each pin would trigger a specific action, a lever pull, or rope release. If you wanted to change the play, you just had to change the arrangement of the pins. You were literally reprogramming the machine. This is the essence of mechanical programming. Later, during the Islamic Golden Age, engineers took this concept even further. They built magnificent water-powered clocks that didn't just tell time. They changed their behavior based on different inputs. For example, a bird might sing on the hour, but only if the sun was up. That's conditional logic. If this happens, then do that. This is the bedrock of all modern programming, and it was happening centuries before the first electronic computer was even a dream. The thread of this story leads us to a pivotal moment in 1801. A French weaver named Joseph Marie Jacquard invented a revolutionary new loom. What made it so special? It was controlled by a series of punch cards. Each card contained a set of instructions, with holes representing a specific part of a pattern. To weave a different design, you just had to feed the machine a new stack of cards. The pattern was essentially loaded into the machine, just like we load software today. This brilliant system directly inspired two of the most important figures in computing history, Charles Babbage and Ada Lovelace. Babbage designed his analytical engine, a mechanical general-purpose computer based on this punch card concept. And it was Ada Lovelace, a visionary mathematician, who looked at Babbage's designs and understood something profound. She realized these machines could manipulate more than just numbers. They could manipulate symbols, concepts, and logic. She then wrote the world's first ever computer program, a detailed algorithm for Babbage's machine to calculate a specific sequence of numbers. She did this decades before a working computer even existed, earning her the title of the first computer programmer. Her incredible insight laid the philosophical foundation for all of modern computing. But the ambition of ancient programmers went far beyond machines. They programmed reality itself. Think about ancient civilizations and the massive, complex systems they built. These were all, in a sense, programs. The Mayan calendar, for instance, was an incredibly sophisticated time-based algorithm designed to track celestial cycles with astonishing accuracy. Stonehenge, the mysterious stone circle in England, wasn't just a monument. It was a solar program built to predict solstices and eclipses. The Great Pyramids of Egypt weren't just tombs. They encoded vast amounts of astronomical data and geometric principles into their very structure. Even human civilization itself can be seen as a system of instructions. Laws, rituals, agricultural cycles, and oral traditions are all sets of rules, passed down from one generation to the next, executed year after year to maintain social order and ensure survival. From this perspective, programming is one of the most fundamental human activities. It's how we've always organized our world and shaped reality to meet our needs. So, when the first electronic computers finally arrived in the 20th century, humanity wasn't starting from scratch. We already knew how to program. We had been doing it for thousands of years. The challenge was simply to translate this ancient logic into a new medium, silicon. The concept of a loop used by ancient builders to lay bricks in a repeating pattern became an electronic circuit. The conditional logic of Heron's automata, if this, then that became a transistor switching on or off. The step-by-step instructions written on Babylonian clay tablets became the binary code of ones and zeros that powers our digital world. Even the most advanced concepts we have today, like artificial intelligence, didn't just appear out of nowhere. They are the culmination of a long, unbroken chain of algorithmic thinking that stretches all the way back to the dawn of civilization. The first programmers weren't engineers in hoodies, working late nights in Silicon Valley. They were ancient mathematicians, brilliant astronomers, and master builders. They looked at the world, saw its underlying patterns and logic, and wrote the instructions that still, in many ways, run our world today. The code has changed, but the fundamental human desire to create order from chaos remains the same. In the next episode, we're going to explore one of history's greatest and most fascinating mysteries, the strange and inexplicable appearance of pyramids all over the planet, built by cultures that supposedly never met. Make sure you're subscribed so you don't miss it. Thanks for watching.